AP, and this would be one where you have multiple masses that are all connected together in some Atwood machine setup. And we have two different strings, so we're going to have two different tensions, but they're all going to share the same magnitude of acceleration. All right, so my acceleration, I am going to guess is going to be 1.4. I'll show you guys how to do this. All right, so I want to get the acceleration of the 4 kilogram block. Why don't I call this guy number 1, call this guy number 2, call this guy number 3. Why don't I do an Fnet for each one of them? Try to draw everything to scale. Let's start with number 3. It has its weight going down, and it would have T1 going up. I'm going to change colors to red. Look at number 2. It would have T1 going up, which is the same length. We're taking it to be an ideal pulley still. And it would have M2G going down, and T2 going down. Let's look at number 1. It would have a T2 of the same length going up, and it would have a shorter M1G going down, because I think all of this is going to go that way. All right, so I'm going to write an equation for each one of these and add them together, and the tensions are going to disappear. So I'll start with the blue one, and for that one, I'm going to say Fnet equals M1A. I'm going to take forces that turn it counterclockwise minus clockwise forces. So in that case, the weight is going to be positive. The weight's directed down. A force down would be in the same direction as this arrow. It would make it go counterclockwise. So I have M1G minus T2 equals M1A. Number 2. Fnet equals M2A. The arrows in the same direction would be positive for this one, right? Because it's also on that side of the pulley. So M2G would be positive, and T2 would be positive. Look, I'm getting a call from the school on my cell phone, but I'm going to ignore it right now. So I'm going to have M2G plus T2 minus T1 equals M2A. So I'm going to write that below here. So I have M2G plus T2. Look at that. I have a negative T2 and a plus T2. The tensions are internal. Minus T1 equals M2A. I just need to do my last one for mass 3. I'm going to say Fnet equals M3A. Now on this side, the tension would turn it counterclockwise, so the tension's going to be positive. So when I do my counterclockwise minus clockwise, it's going to be T1 minus M3G equals M3A. And look what happens when I put this below. Now I have a positive T1 where I had a negative T1. I'm going to add all of these together. And T1 and negative T1 are going to cancel out. T2 and negative T2 are going to cancel out. And I'm going to have M1G plus M2G minus M3G equals M1 plus M2 plus M3 times A. All right, I'm going to erase a little bit of this so I have some room to work up here, because I'm not on the smart board, I'm just on the smart meter. So I'm going to divide by the sum of the masses, and I'm going to get that acceleration is going to be equal to M1G plus M2G minus M3G over the sum of the masses. Let's plug in. M1G would be 1 times 10. M times G would be 10, so I have 10 newtons. M2G would be 2 times 10. I have 20 newtons. M3G would be 4 times 10. I have 40 newtons. And on the bottom, I'm going to have 1 kilogram plus 2 kilograms plus 4 kilograms. What do I end up with? I have 10 plus 20 is 30, minus 40 is negative 10, divided by 1 plus 2 plus 4 is 7, and I should get what I said, which was 1.42. Actually, 1.43. Negative because the direction of this is clockwise, because this is the bigger force. All right, how did I know right away that's what it was going to be? Because I know what my net forces are. My net force is this weight is going against those two weights. This is 40 newtons. Together, those are 30 newtons. That's a net force of 10. So I have a net force of 10. Fnet's 10. How much mass is 10 going to accelerate? It has to accelerate all three of them. So it has to accelerate 4 and 2 and 1. And so I just put 10 divided by 7, and I got the same answer. All right, to get the tension, this is where it gets tricky. When we do the substitution, we have to put in the negative. But it's easy for you to check this because the tension we get for the 4 kilogram block should be less than the weight. It should be less than 40 newtons. Why? Because this block is going down, so this force has to be exceeding the 20. So I'm going to look back at here. I want to get what T1 is. So T1, I'm going to add M3G to the other side. I'm going to put in M3 as 4. Now my acceleration has to go in as the negative. And then M3G is 40, so this is going to give me 4 times 1.43. And I get a tension of 34.3 newtons. So it's less. That makes sense. For the 1 kilogram block, the tension should be more than 10 because this block goes up, it accelerates up, right? So it's lifting it and accelerating it. So I'm going to look at that equation, which I erased. But this would be, I'll make some room for this. This was Fnet equals M1A, and this was M1G minus T2 equals M1A. So I would have M1G minus M1A is equal to T2. So we said this was 10, and this would be 1 kilogram. And again, I need to put in the negative. And so this is going to give us 11.4, which makes sense. It makes sense this tension is less because this force is making it accelerate down. It makes sense that this tension is more because this force is making it accelerate up more.